Welcome to homework.
This is the answer to Chapter 14, problem number 29 from the Smith Organic Chemistry textbook. And in this problem, we're given four molecules, and each of these four molecules has two carbons indicated in each one. And we're asked which of the indicated carbons in each molecule is going to be shifted further downfield. And so to answer this problem, we need to remember that carbons in carbon NMR are deshielded in much the same way as protons are in proton NMR. And so we can actually just apply the same set of rules, and that will tell us which of these carbons is going to show up further downfield. So looking at A, we have diethyl ether, and so we're comparing a carbon that is bound directly to oxygen, which is a very electronegative atom, and a carbon that is not bound directly to oxygen. And so the carbon that is bound to the electronegative oxygen is going to be much more downfield. And so this carbon is going to be further downfield because it is directly bound to an electronegative atom. So then likewise in B, we're comparing a carbon that has a bond to one bromine and a carbon that has a bond to two bromines. And so bromine, like oxygen, is very electronegative. And so two of these very electronegative bromines are going to deshield that carbon more than just one bromine is going to deshield the other carbon. And so in C, we're comparing a carbon that is part of a carbonyl to a carbon that is bound to an oxygen. You could also rationalize this as the red arrowed carbon is bound to two oxygens versus the green arrowed carbon, which is bound only to one. Or you could think about really this carbonyl carbon has three bonds to electronegative oxygen, and the green arrowed carbon only has one. So however you choose to rationalize it, the red arrowed carbon is obviously going to be much more deshielded, and so it's going to show up much further downfield. So lastly, in D, we're comparing a carbon that is part of a methyl group to a carbon that is part of an alkene. And we should remember, so like I said, we can apply the exact same rules that we use for proton NMR. And so protons that are part of an alkene system are always shifted downfield as compared to protons that are not. And the same is true of carbons. And so this green arrowed carbon is part of an alkene. The red arrowed carbon is not. And so the green arrowed carbon is going to show up much further downfield. And so again, that's the way to approach this problem. We just need to remember our rules about deshielding, electronegativity, and the effect of carbonyls and double and triple bonds, and just apply those rules to carbons the same way that we would to protons. And that's the answer to Chapter 14, problem number 29.